Our major challenge is to optimize internal logistics to make the production process as efficient as possible. EMKA Sealing Systems recently built a 4,200 square meters new factory site to be integrated with the current one. After initiating the production in the new factory hall, there is a need for optimizing operations between both facilities. The L4MS project provides the ideal framework and tools to undertake the envisioned process of introducing AGVs. At the moment, EMKA Sealing Systems' internal logistics process is manual, using forklifts. This project represents a big opportunity to design, test, and optimize the behavior of an AGV, modernize the plant, and train the workforce to interact with AGVs. The project will enable EMKA Sealing Systems to elaborate a roadmap for the full automation of internal logistics and will encourage the company to carry out further digitalization projects.
Opel was the core of the experiment. It is in charge of connecting to the AGV and all the different sensors. It is also the platform that allows us to define the tasks that the AGV is going to perform, and it's interacting with the AGV, commanding all the movements that it needs to do and getting the different data from the sensors. Finally, it also displays the information to the operator using the HMI module. We have used the core of the Opel application, of course, so the fewer components like the Rioja context broker and the backend storage, which is MongoDB. We have also used the 4 more important components on the server, which are the task planner, the MTP, the motion task planner, and also the HMI, the hardware machine interface that allows to display information to the user. Finally, in the AGV, we have used the RAM, the robot agent node, and the local sensor and perception module.
We decided to use all Opel components because we were very interested in how they worked, and we wanted to test them in our robot in a real situation. Components like multi-on task planner were used in the Opel server. For example, the robot agent node was installed in a robot to perform the navigation. And finally, the sensor agent node helped us to manage the sensors.
The digital twin simulation allowed us to test all the different components that interact in this experiment.
The main advantage of the 3D simulation was the ability to create an environment and a robot identical to the reality. Thanks to this, we were able to accelerate the integration of the robot in the factory because we could test different scenarios quickly and over again. In this way, when we arrived at the factory, we only focused on testing the real robot and fixing small details.
The experiment at Riogistics that we were part of was a very success for us. We were indeed able to create a new spin-off company, which is called Elliot Cloud, which takes in all the knowledge that we gather from this experiment. We have constructed an IoT platform which connects all sorts of devices at floor plants and at industries, and thanks to this experiment this was possible.